I think we're up and running. Welcome to the fourth lecture in the course. This was what I was about to show. You have the lecture slides under lecture 5 if you want to open them up. I will move them also to lecture 4 because they are shared between these two lectures. So I hope actually today to be able to get into the observer pattern. Last year we did not manage to do so, but this year I have slides for the presentation also, so it will possibly move on a little faster. Some external materials, some articles about graphical user interface architectures by Martin Fowler. Interesting read for you if you're interested in user interface architectures. Concerning the model view design, different variations of the model view design pattern. You can check out the paper there, actually by one of the professors here at Linnaeus, so it could be an interesting read if you're interested in the different kinds of model view patterns that exist. And also a new book. We talked a little bit about this one yesterday, Pattern-Oriented Software Architecture. And we have a new book here also to complement the course literature. Design Patterns, Elements of Reusable Object-Oriented Software. This is maybe the first book on design patterns and in software. And some of these patterns are in the course literature, but this is a more comprehensive collection of patterns, and it's a somewhat of a classical piece in object-oriented design, so you should definitely check it out, I think. The peer review sheet has been posted also. You find it here. So you can find your group, and basically you're supposed to review the two groups that are below you in the list. So you can get the materials using the link available in the sheet. If you have any problems accessing the materials, contact the group responsible. So if there are any troubles there, contact the group that you're supposed to review. Then you have a small list of steps to take here. So this 9th step I actually added yesterday. There were some questions during the workshop on how to react on the feedback you get. And of course you are reviewed by your peers, so it is not certain that you get the, so to say, correct comments. However, comments should be in some way motivated by some external source of some kind of quality. So you have to maybe look further into the comment, the source, and form your own opinion on the feedback. And the idea is, of course, that if you agree to the feedback, when you have learned more, you can change your workshop to incorporate these changes. And also, you should write down what you change and why. So your workshop should contain a small document, changes.txt, for example, with this information. So if you decided to make some changes, just write down what you changed. And if you have version control, that won't be a big issue. You because then you can always just step back a version and check it out. But write down in some kind of text file or something like that a short list of the changes you made and why you made them. So we can see if you have if the peer review gives you any good progress in your work. So, and you have some instructions there also. I posted this link kind of like yesterday at maybe 2 o'clock or something like that, and I did not get any major feedback that there were any problems, so I trust that it will run smoothly. Okay, that's enough administrative talk. So today we will talk about model view controller. We will examine this pattern. We will implement the dice game using a model view controller architecture. Yesterday we did this model view separation. Today we will incorporate a controller class in it also. I hope to be able to add also the observer pattern to this architecture. So, as you possibly remember, a pattern is a named abstract problem and solution. So first, we have the name, model view controller, and we should check the problem out. The problem that model view controller was originally at least designed for, it's quite an old pattern. I think it was in the 60s, early 70s possibly that it was written down in a short technical memo by Trygve Reinskaug at Palo Alto Xerox Research Center. So it's kind of like fun to imagine that his short, maybe 2-page scribble notes almost has had such a huge impact on especially web development the last few years. It's kind of neat. So, however, during that day, the graphical user interface were in their infancies. So the pattern that he envisioned is a little bit different from what we actually see today. And this is also something that we can investigate even further during this presentation. So, but basically what we want to do is we would like to be able to reuse the functional parts of the system. So exactly as in the model view separation principle, if we remove the user interface from the parts that execute the business rules, it becomes much more easy to reuse the business rules with some other kind of user interface. And this could be important as different users often want different kinds of user interfaces in different situations. So one could easily imagine an expert user want a very complicated user interface that lets him access all functionality really, really quickly. So to compare this with a beginner user that maybe wants step-by-step instructions for each operation they want to do, very few choices, default values that are really the most common case for things. And some users maybe prefer graphical user interfaces, others prefer command line user interfaces. So, and we could also have that some user would like to access the system on a tablet or smartphone or something like that. Then we have a radically different kind of interaction with the fingers instead of maybe a keyboard and mouse. So we have a lot of demands from users to have different kinds of user interfaces, both for different kinds of situations and different kinds of users. This means that user interfaces often need to change and evolve because of these user needs. And on top of this, we also have technology that drives a lot of changes in user interfaces. I don't know how often a new flavor comes out in user interfaces, but on the web it's quite often. You get new frameworks, you get new styles that you should maybe have if you would like to have your application to be the latest one. It will look and feel like a modern application. So we have these drivers that constantly push our user interface in different directions. So we need to be able to easily evolve the user interface. Of course, also functional parts can be evolving, and we can add features and remove features, but often at a slower pace, maybe, than the user interface. One problem that they had often in the early days of user interfaces were that, well, this was maybe one of the first times that you could kind of like look at the same information in different kinds of way at the same time. The common example is that you have a table with values. That is one kind of visualization of some data. But you can also look at the bar chart over this information and maybe a pie chart over this information. And you can have all these elements of the user interface visible at the same time. So the same kind of information should be presented in different kinds of way. And also, you want changes in one of these representations to affect the other ones immediately. So if you change the values in the table, the bar chart and pie chart should also change. And also if you kind of like drag and drop a bar or drag it, maybe the table and the pie chart should also change. So you have this kind of like complex interaction between different types of presentations. So if you have problems like this in your application, Model View Controller could be a solution to these. So, onwards, we have talked about the abstract problem. Now we need to talk about the solution. So, not surprisingly, we should divide the system into 3 packages, 3 parts, 3 components, name them what you want. First one is the model. It's exactly as we discussed before, data and rules for implementing the actual functionality in the system. Same concept as in the model view separation principle. Then we have the view. The view in the model view controller is about visualization and low-level input. This component is often about very platform specific. So you could say that it is a more specialized version than the view that in the model view separation principle. Naming here is a little bit confusing, but I think you can manage that. So the view in model view separation principle has been divided into the view and the controller in the model view controller pattern. And the controller then handles interaction. More specifically, often execution of scenarios. So you can often find a controller that is named after the kind of actor you have that wants to do something in the system, with an operation or several operations that mimic what this actor actually can do. So if the actor can play a game, you often have maybe the actor player and the operation play game in the controller. So this provides a division of the user interface into more platform-specific visualization. You can visualize this scenario using different kinds of user interface technology, but the steps are more or less the same, independently of the technology used for visualization. So the controllers are more platform independent than the views that are often quite tightly coupled to some kind of user interface technology. Historically, controllers actually had low-level input in them, and this was before we had these nice APIs and such for handling this low-level input. Then you often had raw mouse clicks, for example, raw mouse coordinates and stuff like that inside the controller. This has often now moved into the view, and sometimes they are also even hidden inside some kind of technology or API that you use. So you don't get raw coordinates for the mouse position and queries the keyboard and stuff like that. Rather, you get some kind of events in the view that you then can translate into higher level events that you send to the controller. The web is maybe a good example on this, because there you get a whole page, a whole form, kind of like submitted into the server. So there you often do not get this kind of like low-level input. Oh, the user has now pressed the A key and stuff like that. So this is a little bit different than the historical model view controller that were really, really small components. Maybe the model was just a value, and the view was some kind of text input field, and the controller managed the interaction between this value in the model, mouse coordinates, keyboard clicks, mouse scroll wheel stuff, and just this small micro architecture, if you would like to use that word. Nowadays, we often have a much higher level here, and we structure the whole application maybe in the model view controller way if we are to use this pattern. So we have these three packages or components or parts of the system. The next step is to define a mechanism to inform view and controller if the model changes. This is somewhat optional depending on your application and depending on your environment. For example, in the web case, this is often not that needed, because, well, you kind of like submit the whole page and the whole server is more or less stateless. So, however, if you make more of a desktop application, then you can have several different users and several different kinds of interaction going on at the same time, and you need some way of notifying these different pie charts or bar charts that the table has been changed and they should update. And of course, the rules are to not put any data and business rules in the view or controller. And this is data that is needed to perform these rules and functionality. You can have data in view and controller that are specific for the user interface. And you can also have state that is specific for user interface, and rules that are specific for user interface in view and controller. So it is important to make this distinction: what is actually part of the domain, what is part of the problem, the functionality, and what is just some extra data that we need for the user interface. If you remember, we had this circle example where we had this big circle class that had a mixed responsibility, both the business rules of computing the area and the user interface to store position and colors and such for the circle. So in this case, we need to have the representation of the circle, the mathematical representation inside the model, and the interactive parts of the user interface for the circle somewhere in the view and or controller. So we need to decide on some kind of division there and how this division is going to be made. And the second one is that the model cannot depend on view or controller. Yes, I will turn the volume down. Speaker. Oh. Need to stop sharing a little bit. Okay, I hope this is a little bit better. Great. So this means that the basic model view controller structure looks something like this. You have the model, and there are no dependencies going from model to anything else. So the model is more or less self-contained. This is something to strive for. The view can depend on the model. The view needs to visualize some element in the model, so maybe it needs to get some data from the model. A list of customers is sent in. It needs to query the customer name, the customer address, to be able to print this in a good-looking list or something like that. However, this relationship, this dependency between the view and the model is optional. It could also be specified as a read-only dependency. So the view is only able to read the data from the model, but not change any data. This could be a good thing to further specify what you mean by the model view controller pattern, so that you don't kind of like mix this and different programmers do things in different ways. If you're really keen on, for example, making a reusable view, some kind of let's say game engine or a protective layer or something like that in the view, then it's a good idea to try to remove this dependency on the model. Because if you do so, you can reuse the view in different projects. If you make a really good XHTML view, for example, that has really good rendering of HTML elements, maybe you would like to reuse that in your other projects also. And then it can't really be dependent on model stuff. So then it can either have its own set of classes to put in data inside the view to get these nice renderings, or you can have primitive data types, of course, like integers and strings and stuff like that. If you do so, the controller has the responsibility to kind of like take the data from the model, transform it in some kind of way, and put it inside the view, so that you get a kind of like translation from a model into user interface by the controller. And this is an option, of course. It will probably make your controllers a little bit more complicated, but that could be a good trade-off if you want a reusable view. So, if we take a look at the controller then, it can depend on the model, and it can also depend on the view. And if it depends on the view, often you kind of like decide that the view should not depend on the controller, or have a very specific kind of dependency. For example, just be able to create controllers and then leave kind of like the execution up to the controller, and no more calls are kind of like allowed in this direction. So often the relationship between view and controller is complicated, and you often need to think more about this. What do we actually want in our application in terms of these relationships? Since the controller is kind of like the middleman between model and view, It often is responsible for executing functions inside the model that actually performs the things that the user wants. And then updating the view accordingly and stepping through the scenario like this. But the interesting and important relationships here are the one between view and model. Should we have it? Should it be read-only? Should we have any other restrictions on it? And the relationships between controller and view. Should we decide on one direction? Should we have both directions? Should we have some kind of rule that states more specifically what these relations actually are and what they are allowed to do? This means that you often cannot just say, oh, we will use the model view controller pattern in our application and then think that you are done. Because if you do so, one person will think in one way and the other person will think in a slightly different way. And when you come down to implementation, you will get these variations and, well, it will be more or less chaotic. So, if you decide to use the model view controller pattern, you can have these multiple user interfaces using the same kind of data and the same kind of rules. You can have synchronization of your user interface. You can more easily change and evolve your user interface without modifying your models. It's quite framework friendly. You have possibly used some frameworks that implement some variation of the model view controller pattern. It's quite test friendly. Often you can have automatic testing of your models. That is often quite easy because you can write a test controller, so to speak, that just test runs your model in different scenarios and checks that the output is correct given the input that it's put into the model. If you're really really good, or you can also test your controllers by mocking your model and your view. Views are often a little bit more hard to test because they require, at least automatically, because in many cases they require some kind of visual checking of that, oh, did this really render as we thought it would. If the goal of the view is to output something more descriptive, like HTML, you can of course have some text checking there to check that, well, this element exists in this HTML source, and it should. So if you have kind of like this descriptive view that is later then translated into something visual by the web browser in the web case, you can also have testing of the view. Reuse friendly. Models are often reusable, at least if you would like to have the same kind of system. Or parts of the model if you have a similar system. In our case, we could probably easily reuse our dice class. Views can be reusable also if you try to make them more self-contained. If they do not depend on the controllers or depend on the model, they should be quite easy to reuse. Controllers, however, are often quite bound to both the user interface and to the application, to the model, so they are harder to reuse at least. And this is not so strange because, well, a certain type of application has a certain type of user interface, and reusing exactly the steps can be cumbersome. Possibly you can have some generic kinds of controllers also. I could imagine an authentication controller, for example, could be quite similar, at least, between projects on the web, if we take that example. One interesting aspect I think that is often overlooked is this mapping of requirements. So you have the requirements in forms of actors, maybe use cases and scenarios. Then you have a mapping from the requirement into the design, the controller, with the name of the actor maybe, with the name of the requirement as an operation. And you can see this in the code also. Since controllers at least can be implemented as scenarios. So they are more or less a step-by-step description of a use case or a scenario in the requirements. And this is quite powerful, since in a maintenance situation you often get a report that says, well, I tried to do this and it did not work. And you need to find some kind of way to know where to start your debugging session. And if you know that, okay, this user is an administrator, he tried to log in, so I can go directly to the login operation of the administrator controller class, then much is actually won. And start your debugging and doing changes from there, instead of trying to search the whole application for something that has something to do with login. So, everything is of course not just good. You also have some drawbacks. And the controller and the views are often bound to the model. We could see this in the structure, especially controllers. Views can be hard to actually get really self-contained, and often it's more work than it's worth. And controllers get more complicated. So it is not easy to have reusable views, and controllers are possibly even harder. Performance, especially in this kind of desktop application scenario, where you have this update mechanism that needs to update stuff. And depending on your level of granularity in this update mechanism, you can have these kind of like really small updates that are sent to every kind of user interface representation, and they need to find out more and render themselves again, and this can become problematic. So you need to find a good level of balance here between, okay, should we just send something has happened and all the views need to check what has happened, do I need to re-render, and this can of course take some time, and then you lose responsiveness of the user interface, and this is not a good thing. Or should we have a very detailed kind of a mechanism where you just subscribe maybe to a certain type of events? I'm only interested in changes in this kind of data. And that gives you often a lot more code to implement. Becomes much more complicated to implement this mechanism, and more error prone. In some place you forget that, oh yes, we should notify all the user interface also in this situation, and you need to know what kinds of user interfaces are interested in this type of change you have. Okay, we have a question. Yes, indeed. There is a lot of confusion about the model view controller pattern. There are absolutely a bunch of variations, as you can see down here on this slide. Different kinds of names, different kinds of more specific ways of dealing with things, and yeah, you need to decide what kind of variation you actually want. And this has to do with that a pattern can only describe an abstract solution, and exactly how you implement this solution is up to you. So you should, of course, bear this in mind when you just say, okay, let's use the model view controller pattern. That almost everyone in your team will have a slightly different point of view and slightly different idea of what you actually mean. So there, especially for this pattern, this is maybe the pattern with the most varieties, at least that I've encountered. So that is an issue in this pattern. Yeah, as we saw, it can be hard to separate the view and controller. You need to decide on the communication between them and the dependencies between them that are allowed. And you can get really fat views. That is a lot of code in the views. The views are really intelligent, and maybe that is not something good in your project. And you can get really, really fat controllers. The controllers do a lot of things, and the views are really, really thin. Just a layer of indirection between the controller and some kind of API. So finding a good balance there is often hard. As we saw actually in the examples that we did yesterday, you can accidentally add some user interface specific functionality into your model quite easily. And in our example, we output this formatted string, and that was quite an example that is quite easy to spot. But there are other more subtle ways that the model can become more or less user interface specific, and this has to do with what kind of services do you add to the model that are actually needed. So, for example, if you have this list of customers somewhere in the model, the user would like to display a list of customers, and you can get the list of customers from the model. That's fine and dandy. The controller can give this list to the user interface, and the user interface can render it as an HTML page or whatnot. But what if we would like to sort this list? We would like to have a sorted list. We would like to have it sorted on different columns, so to speak. So we could sort the list based on the name. We could sort it based on maybe how much the customer bought, and some other stuff. Should we add functionality in the model to accommodate for this? So get sorted customer list and some arguments to this, depending on what kind of like way we would like to have this list sorted. That is one option. Or should we add this functionality to sort the list inside the user interface, because it's just a different type of visualization actually. So we send the whole bunch of customers directly to the user interface, and the user interface needs to remember, okay, the user wants to sort on last name now, so let's do that. And the user interface itself sorts this list. So what should we do? Should we go for a simpler model with just the get customer list? Or should we, and then suffer the consequences in the user interface to add complexity there to get this sorted list? Or should we add complexity inside the model and have a simpler view? Deciding on this is not super easy, and I've got no simple answer for it. But you could imagine, well, getting the list sorted on the customer list sorted. It's just the administrator that actually does this. So it's just a limited part of the application that needs to have this, and adding it in the model would kind of like expose it to everyone that used the model. So in that respect, it's maybe not a good thing. Since this is just a limited part of the user interface, maybe just some on the administrator actor in some kind of scenario where he wants this list sorted in some way, then you add it to the user interface. Another way to think about it is, well, getting the sorted customers is something that everyone would like to do. So adding it into the user interface would maybe be cumbersome. It could be adding a lot of code duplication in different parts. So it's better to add it as a service in the model to get this list sorted. So, and then make the model more user interface specific. You need to maintain this code if you are to reuse it in the next project. This function, what does it do? Do we need it? No, we don't. So should it stay? Should it go? So you get more code in the model to maintain. On top of this, you could ask yourself about performance. If we have 200,000 customers in our list, maybe it's not a good idea to send this to the client if it's a web-based system and there's a lot of information for each customer. It could be bad for performance to not send just the first 10 customers. So adding sorting in JavaScript on the client side is maybe then a bad thing because of performance. And databases, relational databases, they are really good at getting data directly sorted by using some kind of query language. So thinking about performance, maybe you should add this service to the model. On the other hand, maybe the database is a performance bottleneck and everyone queries the database all the time to get sorted customers, and this will cause some kind of performance penalty. Then it could be better to have the sorting inside the clients, actually. So there are no kind of like easy answers here. As you probably see, you can add functionality inside the model or inside the controller or inside the view, and you need to kind of like decide on what level of service should the model offer. And this is very specific for your application, and you need to test these things, of course. What performance do we have on our database in this case? How many queries, how many users can it manage? Can we add scalability to the database to manage a surge of users in our application? And so on and so forth. So just by saying let's use model view controller, it is also not clear in every kind of case what you should put everything. And as I said before, the question here on the chat was about, you have a lot of different names and variations for this pattern. Model view presenter, model view, view model, passive view, supervising controller. There could be a lot of different varieties and flavors of this pattern. So this makes it even more important to be specific when you say that you use it. So, yeah, I think it's time for a break, actually. Time moves fast when you have fun. And after the break, we will transform our dice game into the model view controller pattern. And hopefully, we will also be able to check out the observer pattern in the dice game. But first, 15 minutes of a break.